Another example. Okay, so this is one of the statements we looked at before. P of x is x exclusive or x is equal to x. We already looked at that statement before. And x is a proposition. Its value is either 0 or 1. And we want to figure out for all x p of x. We figured out it was false. But in general, what we're going to do when we're looking at a proposition and we're looking at a quantifier for the proposition is we make a truth table for all x, because then we should have all ones if it for all x is true, right? So we can make x, and it's easy to do a truth table for propositions because we only have two values for the input. Okay, so now I can make separate tables, and I can treat this equals just like I did the logical equivalence earlier when we did truth tables for that. So that's really what it means. Actually, since it's logic, we can do that. So x exclusive or x is going to give me 0 here. It's going to give me 1 there. I'm sorry, 1 exclusive or 1 gives me 0. And this is what gives me 0, 1. So that's true, and that's false. So this would have to be all ones for all x p of x to be true. So, but I can say there exists x p of x, right? Because one of those values in the column is true. So when we talk about an and or an or for a for all, the for all is going to look across, and both of them are going to look across all the rows and see if the output value, if a for all is there, it's going to see if all the output values are 1, and if a there exists is there, it's just going to see if any of them are 1. So remember back to your first homework problem, you had to look at all the possible output values when you had two input values, right? All the possible output functions. So there was only one that satisfied for all x and y. It was true, right? And that was the tautology function, which was all ones. And there's only one where there exists x, p of x would have been false, p of xy would have been false, right? And that's the all zero function, the contradiction function. So there exists x is almost always, there exists is almost always going to be true, and for all is almost always going to be false. So just thinking about the space of things, just the probability is that. So just remembering that, remember that ors are almost always ones and ands are almost always zeros. So both of those actually give you a little bit of insight about these quantifiers. Okay, how about if I ask you this? So what that is asking is there an x that makes p of x false? Yes. So whenever I am going to ask you for a truth value of this statement is true, and it's true when x equals 0. And this statement is true, and it's true when x equals 1. Okay, so we already decided that for all x p of x is false. I'm putting brackets because you guys, you need them when we're going to put in equals, because I'm not claiming anything about p of x. I'm claiming something about the statement for all x p of x. Because if I just put in equals, it's going to go with whatever it's next to. So that would be that it would equal p. I would be claiming that p of x equals 0. Okay. How about for all x not p of x? What is that asking me? That would mean that p of x is never true. So I can look at the truth table and say, well, this sometimes it's true, so this can't be true. So how about not the quantity, there exists x p of x? It's false because this one's true. So the not on the outside just negates this. So if this is true, the opposite is false. So these two things are opposites. They're attached because they are basically the same thing. One's the not of the other one. But notice that the second and last rows don't have the same truth value, right? They got the same letters. So you need to be careful about where the nots are. Okay, so if we have a not next to the predicate, it's very different than having it next to the quantifier. Yes? What if you take the not outside of the brackets? It's the same. So whenever the not is right in front of the quantifier, it applies to everything that the quantifier applies to. So I'm going to ask you guys not to put brackets everywhere just because it's easier to read things with the fewest possible number of brackets. So you could write this like this. You can put as many brackets as you want, and it'll still be equivalent. But I use the minimum number. So a quantifier, by the way, always applies until you have another one, or you stop using the variables. Okay, how about not the quantity for all x, p of x? That's the opposite of for all x, p of x, so that is true.